Our topic today centers on RLC circuits. AC circuit containing three components: resistor, inductor, and the capacitor. The resistor is measured in ohms, the inductor is measured in Henry, and the capacitor is measured in Farad. Most times we have micro units, micro XI units such as microfarad, millihenry, and milliohms, and so on and so forth. So today we're going to analyze this. We have the three components. So the thing we are going to do is to find the reactive, the resistance here, and then the reactive inductive reactance and the capacitive reactance. I repeat, the resistance of the resistor, the inductive reactance of the inductor, and the capacitive reactance of the capacitor. So these are three things we're going to look at as we analyze this. So finding the resistance, first of all, we consider the current flowing in the circuit. That's the first thing we need to do. And then the current we have using Ohm's law, IRV, okay? V equal to IR, that's Ohm's law. So from there we can now define the resistance, which is VRMS, because it could be the source is VRMS source, okay, which can be V0 sine 2 pi Ft, so to say, plus some lag if there is anything like that. Okay, we still have to get our current here, I0 equals to V equals to I0 peak current, okay, sine 2 pi Ft. This is Ft, right? And some lag. So that is it. So if we have this, it could be over I, it could be RMS, okay? That's for resistance. What about the inductor? The inductor, we are going to find the inductive reactance by taking care of XL is equal to 2 pi FL, where F represents the frequency. Yes, frequency most times is between 50 Hz / 60 Hz. So we take care of that. So that is it. By the time we know the value of the Hz, of the frequency, which is either 50 Hz or 60 Hz, and then substitute the value of the inductor L and substitute, we now find the inductive reactance of the inductor given as this. So with this, we get that. What about the capacitor? The capacitor is also a component whose capacitive reactance must be found. And to do that, we have capacitive reactance XC is given as 1 all over 2 pi FC. And again, we have frequency either between 50 Hz or 60 Hz, so to say, and we substitute accordingly. Then we have the value of the capacitive reactance of the capacitor. Okay? Now, since we have identified this, all things being equal, we need to understand that we still have our root mean square value of the voltage as all that V0 sine 2 pi t, and so on and so forth. Okay? If we have that with this, or sine omega t, so that is it. If we have this, okay, we can now move on. We can still restate this. We can just put this as sine or omega t. All right, we have omega. We can still state omega as 2 pi f. So if we substitute accordingly, we have something that resembles this V Rnx is equals to V0, which is the peak voltage value, sine 2 pi Ft. If there is any lag, maybe lag or lead, we have plus or minus that factor. Okay? So that's what it means. We're going to have the same thing when we have the root mean square value current, we can still use this, find it as this sine 2 pi ft plus or minus certain factorial lag or lead. So that is it. Okay? Now we have another one. If that is given, we can still have root mean current RMS is equals to I naught all over root 2. Still okay. So all these formula, there are things we need to use each time we want to solve a particular question. Alright? So it's not something so difficult. But there is something we need to understand. The general opposition offered in an RLC circuit is known as the impedance. I repeat, impedance of an RLC circuit is the general opposition offered by the three components in this condition. So if we want to find the impedance, impedance is Z, represents impedance. Impedance is also measured in ohms, okay? So if we have this and we want to calculate the value of the impedance, it simply means we need to take into consideration all that we've got. It simply means we have to take into consideration all that. And how do we do that? It's very simple. We take note of R, which is the resistance of the circuit, plus, bracket open, the inductive reactance minus the capacitive reactance, all squared. So by the time we evaluate that, we now find the value of the impedance. Like I said earlier, the impedance is the total opposition offered in an RLC circuit when there is current flow, right? So the opposition RLC offers in this kind of circuit is referred to as the impedance. That's the name, impedance, and is measured in ohms. So with that, we have analyzed this. Of course, if we want to calculate the individual potential difference across each of the components, so we can consider this VR for resistor, VL for the inductor, and then VC, the potential drop across the capacitor. We can take Ohm's law into consideration and also consider other formulas that were stated here. This is V naught to avoid confusion. Alright? Okay, and some factors. I want to explain these factors. We have plus upon minus here. You usually have plus upon minus somewhere here. And that's phi. That letter, this is a Greek word known as phi. Phi again. So why do we have plus upon minus? In my previous video, I discussed a situation where an inductor is connected in an AC circuit with the voltage. It is either it is leading the voltage with some amount of factor pi over 2, or the voltage is lagging behind. So plus means if it is an inductor. If it is an inductor, it means that the inductive current, alright, leads. That's going to be plus. But if the inductive current lags, okay, current this side is going to be minus. If it's the voltage that leads, it's going to be plus. But if it's the voltage that lags, it's going to be minus. So that's the essence of plus upon minus, in case for clarity purpose, okay? Alright, so in my next class, what we're going to do is to solve problems on this, where these three components are L and C are connected, and how we're going to find the total impedance. So that's what I'm going to do in my next class, and we're going to see how that is resolved. So, before I let you go, remember to smash the bell button on and then share with your friends, network, and then students. Put on the bell button for constant notification, and don't forget to subscribe. Subscribe, and content like this will always come your way. Thank you, and see you in my next class. Somewhere there it will be linked, or somewhere there.